This is a model of the Arctic Ocean and the Atlantic Ocean right around Iceland. The Arctic Ocean is on the right and has blue-colored water in it that is very cold, so it stays on or near the bottom. And the Atlantic Ocean is on the left. And I have it ice packs here so that the water stays cold in the Arctic Ocean, since I can't simulate the formation of sea ice in this setup. But I do have a heater over on the left side which warms things up. Now if you notice here, the setup is such that there is a piece of plexiglass that runs all the way across that holds the water in the Arctic Ocean, except for a narrow cut right there. That narrow cut is the Faro Trench, and the piece of plexiglass that's going across simulates the Greenland-Scotland Ridge. As water from the North Atlantic Drift goes up past Scandinavia, it cools off by evaporation and gets a little bit saltier, and then it cools off even more and starts forming ice. But ice excludes salt when it forms, so the water underneath the ice gets quite a bit saltier, and it starts to sink, and it falls down to the bottom of the Arctic Ocean, just like the dark blue water here. That's very cold water and is being kept cold by those ice packs. When it reaches a certain level, this cold water spills out over the Greenland-Scotland Ridge, through the Faro Trench and also the Denmark Strait, and falls down into the abyssal plain of the Atlantic Ocean, as you can see right here, going down into the Atlantic Ocean. This cold, deep water then also has to go somewhere, so it stays deep because it is very cold and salty, and it goes southward. Now we can't look at the entire thermohaline circulation, but we can look at what is happening here. The heater on the left-hand side is warming things up just like what would happen throughout the rest of the oceans of the world. Warm water circulating back near the top. You can see blue along the edge here, and you can see blue on the top right here, and that is the thermohaline circulation working. So that warm water circulates along the surface of the Atlantic up towards the Caribbean, where it is warmed substantially and forms the Gulf Stream, which eventually becomes the North Atlantic Drift, and everything goes all the way through. So you can see the entire circulation pattern from very cold water falling down through here to the abyssal plain, to warming up along the side and flowing backwards towards the Arctic Ocean. This is how this system works. About 10,000 years ago, a very large lake in the middle of the North American continent, what's called a proglacial lake because it formed in front of the receding glaciers. This lake held somewhere between 3 and 5 times the amount of water that the Great Lakes do today. And it was called Lake Agassiz. It was held back by an ice dam that eventually gave way and sent this water into the North Atlantic through the Labrador Sea, and it covered the surface of the ocean with very cold fresh water. Now fresh water, even if it's very cold, is less dense than salt water. So it sat on top of the ocean and didn't allow this part of the circulation to work. We're going to simulate this now. The salt water, or the tank is full of salt water that is approximately the same saltiness as the North Atlantic, right around 30 to 35 parts per thousand. And I am going to put fresh water of a different color in here so that you can see. As soon as things settle down a little bit, and this lens has formed, you will see that the amount of blue water that is coming out of the Faro Trench stops. Right now, the thermohaline circulation, at least in this model here, has stopped, except for maybe just a very little trickle, much less than it was before. This event that happened between 10 and 11,000 years ago is called the Younger Dryas event. And it was a very important time in Eastern North America and Europe because it plunged those parts of the world into another ice age for about 1,000 years, because it stopped the thermohaline circulation, at least in the Atlantic Ocean. There are other places along the coast of Antarctica that do produce sea ice, so this same kind of thing can occur along those places. So the thermohaline circulation throughout the world was not stopped. But as far as the thermohaline circulation in Europe, it was stopped. The temperature of the water that I put in, the fresh water, was 7.2 degrees Celsius. The temperature of the water in the tank is about 8.3 degrees Celsius. And in the Arctic Ocean model, continuing to go down, it'll probably stop right around 7 degrees Celsius. So it basically trapped that really cold water in the Arctic Ocean, stopped the thermohaline circulation in the Atlantic, and plunged the eastern half of North America and Europe into another ice age for about 1,000 years. And here you can see, after things have settled down a bit, the thermohaline circulation down into the Atlantic abyssal plain has, for all intents and purposes, stopped. But you can see the warm water trying to push this cold fresh water away and into the Arctic Ocean.